it happened without warning. A silent titan from beyond our solar system just slipped into view, an object the size of Manhattan, hurtling toward us at over 37 miles per second. Tonight, NASA confirmed it's not an asteroid, not a comet born here, but an interstellar visitor named 3I-ATLAS. Imagine something forged around another star, carrying secrets of worlds we've never known. Right now, it's drawing closer, skimming past Jupiter's orbit, on a path that will swing it within 150 million miles of Earth later this year. No one saw its origin. No one can predict its next move. Science fiction just came alive in our skies. What is it really? Is it a harmless relic of cosmic dust? Or a clue to an entirely new chapter in our story? Stay with us, because by the end of this video, everything you thought you knew about our place in the universe will feel smaller, stranger, and infinitely more thrilling. On July 1st, 2025, the Atlas Telescope Network in Chile spotted a faint, fast-moving point of light in Sagittarius. At first glance, astronomers thought it was a distant comet, but the trajectory was all wrong. Overnight, archival data from Japan, South Africa, and Hawaii confirmed its hyperbolic path, a one-way voyage through our solar system. The realization hit like a thunderbolt. Humanity had its third confirmed interstellar visitor. Measuring nearly 12 miles across, 3I-ATLAS dwarfs most known comets. Traveling at 37 miles per second, it blazes past planets faster than any object we've tracked. To put that speed in perspective, it could cross the continental U.S. in under 10 minutes. Its immense size and velocity hint at an origin in a massive active star system. Perhaps a cataclysmic event hurled it across the galaxy. Early spectroscopy reveals an icy nucleus cloaked in a halo of dust and gas similar to comets born here, yet chemically distinct. Preliminary readings suggest traces of exotic organic molecules, perhaps the raw ingredients for life itself. Each flare of its coma releases microscopic grains that may carry amino acids beyond anything found on Earth. Unlike asteroids bound by the sun's gravity, 3I-ATLAS follows a hyperbolic arc. Its eccentricity above for ensures it will never return. After its October 2025 flyby of Earth, it will plunge back into deep space, vanishing forever. This fleeting encounter underscores our urgency. We have only months to learn everything we can. On October 31st, 2025, 3I-ATLAS will zoom within 150 million miles roughly, the distance between Earth and the Sun. That's a guaranteed safe pass. But close enough for powerful observatories to capture high-resolution data. Amateur skywatchers, armed with backyard telescopes, could witness a dim but discernible smudge against the star field. From August through October, 3I-ATLAS will trek across constellations, Sagittarius, Capricornus, and Aquarius. Online star charts and astronomy apps update nightly coordinates. Imagine the thrill of pointing your telescope and knowing you're tracking a messenger from another star. As 3I-ATLAS nears the sun, solar heating could crack its icy core, spawning dramatic outbursts, or even total fragmentation. Will it disintegrate into a spectacular meteor shower, or survive intact? Scientists worldwide are racing to model its structural integrity and predict its behavior. Some fear hype will overshadow hard research. Yes, the optics will be breathtaking, but the true prize is data. Isotope ratios, organic signatures, dust grain morphology. Teams at ESA, NASA, and universities are coordinating round-the-clock observations to capture every fleeting moment. Projects like the International Comet Hunters Network invite amateurs to upload images and brightness measurements. Your backyard snapshots could fill critical data gaps, helping professionals refine orbital models and composition analysis. Visionary engineers propose launching microprobes on hypervelocity trajectories to intercept 3I-ATLAS. These shoebox-sized spacecraft would fly alongside the object, sampling its coma and sending dust particles back to Earth. Such a mission would break speedrec and revolutionize planetary science. Every new interstellar object challenges our models. 3I-ATLAS could carry materials shaped in vastly different stellar nurseries. By comparing its composition to solar system bodies, we refine our understanding of how planets coalesce under diverse cosmic conditions. Could 3I-ATLAS be carrying the very spark of life itself? Picture this. deep within its frozen heart. Microscopic factories of organic chemistry churned silently, long before the object ever left its home star system. News alerts flash. First evidence of alien amino acids detected. Laboratory hoods lift around the globe as chemists and astrobiologists rush to verify the signal. Enthusiast forums buzz with excitement as users share annotated spectra, pointing out faint absorption features at precisely the wavelengths tied to prebiotic molecules. The absorption peaks sit at slightly shifted frequencies, suggesting alien variants of familiar molecules. Perhaps the glycine analog has an extra methyl group, or the adenine-like base carries a rare isotope signature. These subtle differences hint at a biochemistry that diverged from Earth's pathin, independent origin of life, or at least of its chemical precursors. Suddenly, the narrative deepens. Life's recipe isn't a single universal cookbook but a multiverse of culinary possibilities, each star system experimenting with its own ingredients and cooking methods. Some amateur setups near dark sky preserves managed to capture glimpses of the object's dim glow, their passion turning the scientific process into a global, participatory event. Teams propose follow-up missions, a constellation of microprobes that could intercept fragments of 3I Atlas, capturing dust grains in aerogel collectors and returning them to Earth for laboratory analysis. Futuristic designs envision carbon composite sails that unfurl to match the object's trajectory, braving extreme speeds to rendezvous with the interstellar traveler. Engineers debate propulsion methods, ion drives, solar sails, even nuclear thermal rockets pumped with liquid hydrogen to chase a target moving at tens of kilometers per second. Even schoolchildren tune in via live streams, eyes wide as professional astronomers explain how these tiny molecular whispers could answer the oldest question: are we alone? The air crackles with anticipation. Could the building blocks of biology be universal, scattered throughout the galaxy like seeds on a cosmic wind? Headlines erupt, social media erupts louder, debates flare between skeptics demanding rigorous proof and dreamers convinced we're on the brink of a monumental paradigm shift. As it hurtles through space, reservoirs of ice-trapped molecules forged in distant nebulae, complex chains of carbon, hydrogen, oxygen, and nitrogen assembled over eons. Glycine, the simplest amino acid. Adenine, a foundational nucleobase. Even lipid-like compounds capable of forming primitive membranes, all waiting in stasis for a closer glimpse of a star's warmth when 3I Atlas swings past the sun. Powerful spectrometers aboard space telescopes and Earth's largest observatories will scan its glowing coma for those telltale molecular fingerprints. Imagine the moment the data streams in, a spectral line at 3.4 microns that can only be attributed to glycine. The world holds its breath. Citizen science platforms light up overnight. Amateur astronomers and hobbyists upload their own spectral observations, comparing them against NASA's official channels. But then comes the twist. The spectrum isn't a perfect match to Earth's organics. Scientific papers appear within days, posted as preprints on open-access servers. Meanwhile, the broader implications ripple through society. Philosophers and theologians weigh in. If life's raw ingredients are ubiquitous, theories of human exceptionalism face a reckoning. Art and literature respond, and kind poets compose odes to the icy messenger that arrived unannounced. Painters create interpretations of its ghostly visage against a starry backdrop. And filmmakers pitch documentaries on the hunt for cosmic amino acids. On Reddit threads titled R Astrobiology, contributors post fan art imagining primordial soups swirling not in Earth's ancient oceans, but in cryovolcanic plumes on distant exoplanets. Yet uncertainty simmers beneath the excitement. Could the spectral signals be contaminated by Earth-origin organics blown into space by comet impacts? And among them was 3I Atlas, fleeting link to life's universal truths. The search for prebiotic chemistry continues, and with every new object we discover, we inch closer to understanding our place in the cosmic tapestry. Who knows what the next interstellar wanderer will reveal? Keep your telescopes trained on the skies, because the universe is ready to surprise us again. Are the spectral lines truly from 3I Atlas, or artifacts caused by instrument noise? The window of opportunity will close in December 2025, leaving only archival data to sift through for years to come. Yet the legacy endures. Telescopes are upgraded, new missions greenlit, and international collaborations forged in the heat of pursuit. The story of 3IATLAS becomes a rallying cry for global science. Proof that even the smallest grains of cosmic dust can unite humanity in a quest for truth. Rigorous cross-checks and extended observation campaigns stretch into weeks, balancing the mad dash for discovery with the need for unassailable proof. Each new dataset brings revised conclusions. First, an unequivocal detection of glycine analogs. Then a retraction as calibrations are refined, followed by a renewed announcement confirming complex nitriles instead. The back and forth fuels public fascination. The scientific process laid bare. Messy and enthralling, with humanity collectively watching as knowledge crystallizes from chaos. As 3IATLAS recedes toward the outer solar system, its coma fading. The final observatories scramble to capture last-minute readings, and so we were left with questions that echo across the void. Did 3I Atlas carry the seeds of life from a distant world? Or were its molecules mere cosmic detritus, shaped by random chemistry and chance? Could future interstellar visitors bear living microbes, dormant spores awaiting activation? Or is Earth's biology an extraordinarily rare accident, a precious anomaly in a sterile cosmos? The answers remain out of reach, but the journey, and the quest itself, has already transformed our perspective. Today, when you gaze up at the night sky, remember, between the stars, drifting silently, are messengers of untold stories. Could you feel the excitement? Across every platform, #InterstellarVisitor is trending. TikTok creators are filming reaction videos as they track its path across the night sky. Twitter feeds are flooded with jaw-dropping images from amateur and professional telescopes alike. Hashtags like #3IATLAS, #AlienComet, and #CosmicCourier light up timelines around the clock. Even late-night talk shows can't resist dedicating monologues to this cosmic trespasser. Joking about alien Airbnb, or posing tongue-in-cheek questions, do we tip if it leaves lithium instead of cookies? Beyond the memes and laughs, serious conversations are sparking everywhere. Online forums debate whether this object could carry alien life's blueprint. Even fashion designers are getting in on the act, releasing limited edition t-shirts emblazoned with "I saw 3I Atlas" and glow-in-the-dark prints of its icy coma. It reminds us why we look up at the night sky. For mystery, wonder, and the possibility that we're part of something far bigger. It taps into our collective imagination, inspiring a surge of creativity, dialogue, and shared awe. In a world often divided by borders and beliefs, the arrival of an interstellar visitor has united us under one sky, and for now, that's the greatest impact of all. University lectures have opened their doors to public live streams, drawing thousands of viewers hungry for expert insights. Children in pajamas gather in virtual planetarium tours, their eyes wide as they learn that something from another star system is sailing through our own. Artists are tapping into this wave. 2 street murals depict the gleaming silhouette of 3IATLAS against a mural of Earth. Gallery exhibitions feature space dust installations, and poets post free verse odes about frozen wanderers. This isn't just a news story, it's a cultural moment. While 3IATLAS poses no collision risk, its passage reminds us of potential threats, comets, or asteroids on collision courses. Strengthening detection networks and developing planetary defense strategies have never been more urgent. Interstellar objects are likely more common than our scant records suggest. As detection technology improves, dozens may soon be unmasked each decade. The era of interstellar archaeology, studying star system relics without leaving Earth, is dawning. This isn't a passing cometites, a cosmic telegram from another star, brief but unforgettable. 3. I-Atlas has pushed open a door to worlds we've only dreamed of. What secrets did it carry in its frozen core? Will its passing spark the next leap in space exploration? Or will it vanish like a phantom, leaving behind only questions and wonder? Smash that like button if you believe we're on the cusp of discovering life's universal story. Subscribe to the Daily Scope and ring the bell, because the next interstellar visitor could be bearing answers we never imagined. Drop your wildest theories in the comments. What do you think 3I Atlas really is on ice? Rich time capsule, or a messenger of something far stranger? Your voice could be the spark that ignites humanity's greatest cosmic chapter.